Hi everyone, good morning, good afternoon, good evening. Welcome wherever you are in the world to this ML4 Beginners Q&A session. Now, this is a Q&A session. We're here to talk about machine learning, go through some of the things from the videos that you hopefully would have watched on Monday, but this is Q&A. This is for your chance to ask us questions. We want you to dive in the chat. We want you to talk to us. And to do that, we also must insist that you follow our code of conduct. We're going to get that dropped in the chat with a link to it and all the text of it. But please, you must follow our code of conduct or we will ban you from all Microsoft events. That's pretty much how it works. Yeah, we'll put all the details there, but essentially, don't be a jerk, be nice, be kind, and join in, have a chat, be willing to learn. So with that, welcome to our Machine Learning for Beginners Q&A. We're on week 2. We're looking at linear regression. And once again, I'm joined by the incredible Bea Stollnitz, who is way smarter than me, and I'm super privileged to have the opportunity to stream with her. So Bea, do you want to say hello and introduce yourself?
Hello, everybody. I'm very happy to be here again, and I can't wait to see what questions you have today and what you've been doing with AI. And we already have 2 people saying hi from very interesting places.
Yeah.
Okay.
Yeah, Rehab from Egypt and Victorino from Mozambique.
Wow.
Nice. First time folks from Egypt to Mozambique.
Yeah.
So welcome. Glad to have you here. And yeah, if you want to dive in the chat, say hello, let us know what you're learning about machine learning. Let us know if you watch the videos, because the structure of this series is we release some videos on Monday. Thursday, we try and work through the content, but if it's anything like the last few weeks, it's been answering most of your questions. And then Friday's supposed to be about questions, but obviously we're going to answer your questions, and we'll probably will go through some of the content that we didn't cover off yesterday because of questions. So welcome everyone. Welcome just for you again. And Dariush and Marek, glad to have you here with us. And Anil from UK. Don't remember your name here before. So if you're new, welcome. It's really cool to have some old friends back with us who've joined us on all the other series. So, and Quinsap as well. Happy Friday. Yes, happy Friday. If it's Friday where you are in the world, if you're up very early in New Zealand, happy Saturday. So welcome. So this series, we are focusing on machine learning for beginners. Now, machine learning for beginners started out as a curriculum that we built at Microsoft for you. I'm going to add my screen to the stream. I'm going to drop a link in the chat if I can type properly. aka.ms/ml-beginners. So the link I just dropped in the chat is our 26 lesson machine learning curriculum. We built a couple of years ago. We're constantly updating it. This is free for you to use to learn classical machine learning, and we go back to the basics. This is not about using any particular tools other than notebooks. It's the most basic set of standard tools you'd want to use, and we teach you the fundamentals of classical machine learning, really right from the basics. This is designed to be everything from self-guided learning to even a university course. So if you're watching this and you're a professor, lecturer, or you run a computer science club at university, you can just use this. It's free, it's open source, it's MIT licensed. You can take it and do what you like with it. And we cover machine learning around the world. So we have themed lessons across different parts of the world, from American pumpkins, which is what we'll be looking at the moment, to Nigerian music styles, Asian cuisine, world power, romantic hotels of Europe. There's a lot of good stuff there as well. And then what we've been doing is doing some videos. So we stuck Bea in front of the camera in our studio here. And I've forgotten what the link is. I'm going to just... Is it video or videos? Yes, it's videos. So let's drop a link into that. So we've recorded a series of videos. So every Monday we drop some videos. Last week we dropped some introductory ones covering intro and history. This week we dropped some introduction to regression, where we go through regression. Next week we've got more stuff with regression, and then the week after that, well, 2 weeks after that, we're going to drop some videos on logistic regression. So the idea is we drop these videos, you can watch them on the Monday, and then you come and join us to chat. So welcome everyone. Welcome to Jowd from London, not very far from Anil, and welcome Mark from the US. And welcome Nicole. Glad to have you with us. Yep. I hope these links are useful. Yeah, so if you've watched any of the videos, please let us know. Good to know what you know. But essentially, what we're going to do today is we're going to work through some of the content. Yesterday, we looked at running a regression model against a diabetes data set, but today we're actually going to dive in a bit more about linear regression, learn a bit about it, and actually start playing with some data, getting some data ready, visualizing some data ready for next week to really start diving in with some regression models. But this is obviously, it's a Q&A, so you can interrupt us anytime with your questions. The end goal of this is to help you. So whatever questions you've got, please jump in and ask your questions. And Bea's disappeared. So I will apologize. Bea has been having some internet issues. Can I add Bea back? No, Bea's been having a few internet issues. She had some last week. If you watched the stream last week, she dropped off and then reappeared. So okay, can we get Bea back?
Oh, I'm back. Yay!
Yay! Bea's back.
Camera started. Sorry if we're having some issues here. I don't know what's going on. I feel like we're, I'm connected to Ethernet and whatever, but let's hope I can last until the end.
Yeah, we'll chug on through. We'll see how far we get. And if not, I will just make stuff up because Bea is the expert here. I am not.
You know a lot. You know a lot, Jim. You know a lot.
Thank you for your faith in me, but yeah, I'm definitely not. I'm not the expert here. It's Bea's being polite. I'm not the expert, so hopefully we'll keep Bea on board for the entire time. So let's do some regression. Let's actually play with some code. So Bea, what exactly is linear regression? Do you want to give the quick 5-minute intro to linear regression while I dig out the code?
Yeah, for sure. Yeah, so linear regression essentially allows you to find a numerical, like a mathematical expression that represents the trend of some data. So for example, I think we have some good images, probably not in that one, probably in the other one.
It's the one.
The other one, yeah. Yeah, so this kind of explains like visually what regression is. So let's say if you have a bunch of data points of data that you collected, any data really, and you plot them in a graph, in this case it's 2D data, but just you can generalize it, but let's just think about the simplest scenario, which is 2D data. If you plot your points, there will be some line that approximates the general trend of those points, right? And that line can be represented with a mathematical expression. So linear regression allows you to find that line, right? And we talk about, in this week, we're still talking about like regression at a high level. So there's linear regression that allows you to find that line. There's polynomial regression, which is just a generalization of linear regression that allows you to find any kind of curve just by adding more terms to your mathematical equation. That you can like represent any shape. If you have like funky data, you can like draw a line that kind of approximates that funky data. And then in 2 weeks from now, we're going to go deeper into logistic regression, which is more for scenarios where you're classifying something. Like, so for example, here, your y is a numerical value. Like you let's say you look at the price of pumpkins, which is going to be our scenario. Look at the price of pumpkins in many different days of the year, and you get a price, which is like a number that can be anything. But in logistic regression would be more like if you have a category. So for example, if you look at the price of pumpkins, and then you look, is it orange or white? Like you have like 2 categories. It either can be orange or it can be white. But we're going to get into that like later in a couple of weeks from now. For now, we're just talking about linear regression, which is when you're trying to predict just a numerical value, basically.
And it's trends, isn't it? I think we touched on this a bit yesterday. It's not accurate. It's not like you can put in every single one of these points and get the exact number back. It's a general trend. It's, the line does not hit every single point. And if it does, then that's a bad thing because it may not hit new points. You've got to have this trend, isn't it?
Yeah, exactly. So the little points, the yellow points are really your training data. So the data that you use to train your model. And then the orange line is what you're going to be using to make predictions for new points. So for example, in our scenario where you look at the price of pumpkins for different days of the year, the yellow lines represent different days of the year that you went and you looked up, what's the price of pumpkins today? And then you make an observation, and then you plot them in the graph. But then once you create a model with that, then you can ask the model the question like, okay, so generally on the, what is today, 12th of May, what is, what can I predict the price of pumpkin to be? So in that case, you would go and you would look at the orange line, right? You would look at 12th of May on the X line, and then you'd see what is the Y value on that line. So the line is really allowing you to make predictions, and the yellow points are your observed values, like the things that you've collected, the data that you collected. And Jim is right, like you cannot, like it doesn't really work to like make a super curvy line that hits every point. That wouldn't be better than just doing a straight line, because then it would be overfitting to the data. Like it would work well to predict values that you've already seen, but it wouldn't generalize as well for future values. And so the goal here is not to hit every point, but to just like represent the general trend of the points that you've seen in an approximate way. And that's generally what you want when you're making predictions.
So a question from Marek, I guess you kind of answered it, but it's, can we predict future values of price for unknown data? And that's kind of the idea, isn't it? Because you've got this line, you can then use this to predict values for data that you don't have. If you have this line, you may have a point on the x-axis somewhere over here, and you can go up and like, yes, it'll be roughly here on the line, which is this value.
That's exactly right. And Marek is really, that's exactly the whole point, what you said. So you're getting it. You're totally getting it if you're asking that question. The whole point is really to be able to predict price of pumpkin for days that you haven't seen, that you don't have recorded. That you didn't gather data for those. So that's the idea. Like you gather data for a few points, but then let's say for a few days in the year, you have like a couple of days a month, you record the price of pumpkins. But then in the future, if you want to predict the price for a day that you didn't observe, then you go and you look at the price on that line, on that prediction line. So that's exactly right. That's exactly the point.
But I guess also it is a guess, isn't it? It is a prediction, because if you think about the price of pumpkins, I mean, that's obviously what we're diving into. If you were to just plot data from September, August, September, October, you would see the line going up because everyone wants pumpkins in October for Halloween. Something I've discovered. I moved to the US 4 years ago, and Halloween, you put piles and piles of pumpkins outside your house. It's a big thing. You go to the pumpkin patch and cut pumpkins. But in November, no one cares about pumpkins anymore because everyone's thinking about Thanksgiving. So if you only have data for like August, September, October, you'll get a line. If you then use that to predict a value for December, you could be wrong. Very, very wrong, because the price will plummet in December because no one's interested. So it is that. It's not guaranteed, is it? It's the more data you've got, the better you can get your line, but it still is. It's an educated guess. Would that be a fair way to describe it?
Yeah, that's a great word for that. Absolutely, yeah. It's an educated guess, and the more data you have, obviously, then the better your predictions will be, right? Because then you start understanding the trends a little bit better. But you can always make some prediction with some data, right? It just may not be a very good prediction if you don't have a lot of data. So, or if your data doesn't show any patterns, like even if you have a lot of data, but the data is like all over the place, then you may not be able to see a trend. If your data doesn't have a trend, you can't find a trend that is not there, basically.
Yeah, and even if there is a trend, it could be at different time points. The trend just doesn't work anymore because of the data you've got. It's why I guess things like no one's built the perfect linear regression model to predict stock prices.
I wish they had. I wish it was me. I wouldn't share it with anybody. I was just like, ooh, I guess that one, right?
Yeah, if you can do that, you'll be sitting there on an island somewhere, whatever.
That's right.
But yeah, because there's so many inputs to that. Obviously, yes, you can look at the economy in general, but all it takes is for a company to announce layoffs or an acquisition or something that you cannot actually predict, and then the model just breaks completely. You cannot bring all the inputs in. So Jawad has got a great question, actually. I know we touched this a little bit yesterday, but how do you handle outliers and how much they affect the results of the model?
Yeah, so there's two ways to handle outliers. Yeah, we did touch on that yesterday. So you can handle them in the data cleaning phase. So before you even do the model, like if you see that there's something just completely out of whack and you're like pretty sure that it was like some measurement error or data entry error, then you just clean it at that point, right? So, and that actually emphasizes the importance of doing data cleaning, because, you know, if you just like throw a bunch of data that you don't understand into a model, you know, you may not get great results. It always pays off to actually look at it, think about it, and see if there's anything you need to do to it to then be able to analyze it and to draw conclusions from it. So basically, if you put garbage in, you're going to get garbage out, right? So you want to make sure that your data is clean so that you get clean results out. And then another way is there's also in the, when you're evaluating the like accuracy of your, like the quality of your prediction, there's also ways to like, again, I don't want to get into that because it's a bit more advanced, but there's ways where you can give more importance to outliers or less importance to outliers, you know, have them affect more the accuracy or have them affect less. But we don't get to that into that in the course. So let's just say that you do it in the data cleaning area section, you know, when you're dealing with your data.
I guess this is where a domain expert helps, because as a data analyst, data scientist, data cleaning person, machine learning engineer, kind of whatever role you're taking on, those outliers could be important. And unless you have a domain expert,
right,
you may not know this. It's like, just think about pumpkin prices, for example. I know in Japan, they will grow watermelons in glass boxes to make cube-shaped watermelons, and they're so much more expensive. So you could have some outlier pumpkin prices that are not outliers because it's bad data. It's outliers because someone has grown them in a glass box. You have a rectangular pumpkin or something like that. There's so you'd need that domain expert to actually go back and say, is this just garbage data, or is this actually something I have to consider? And if it is something I have to consider, can I clean my data to remove all my cube pumpkins or whatever? So that domain expert is probably useful.
That's so true, Jim. That is very true. Like, yeah, like I wouldn't, you know, as a data scientist, you know, don't just like start cleaning at everything that doesn't follow, just so that you make the points follow a trend, right? Like every point that you clean, just make sure that it's really an error and not just an actual outlier that you want to take into consideration. Yeah.
So Marek follows up with that to say, sometimes for example, cancer prediction data, you don't clean the outliers because the outliers are what say the person has cancer. Is that true?
Yeah, I mean, I wouldn't call those outliers. You know, I would call that maybe like an unbalanced data set. Like if you have lots of, you know, negative results and then just a few positive, I would call that, yeah, I know it's an unbalanced data set. And it brings its own problems when you have unbalanced data sets. There's techniques that deal specifically with scenarios like the one you just mentioned. They're very used in healthcare. But yeah, I like outlier. When I think of outlier, I mean more like, you know, literally a data entry error or like something that is just way off, like that you're like, oh, you know, somebody made a mistake here. Yeah.
Okay, so just think about the unbalanced data set then. If you're measuring for like a blood marker for cancer, for example, if you screen 1 million people, you're only going to have, you know, 10 people who have cancer. I'm making these numbers up for the purpose of illustration, but so you're only going to have 10 data points that say yes, it's cancer, and 990 data points to say it's not cancer. So that's that very unbalanced set.
Exactly.
Right.
That's exactly it. And there are techniques. I'm trying to remember. There's one technique that I've used in the past. Maybe I just go to my GitHub because I did a project with unbalanced data. See if I can find it.
Because I guess that in the medical industry, that would happen a lot. And I mean, even in other industries, thinking back to IoT and kind of my background, if you're doing predictive maintenance, the majority of the data you're gathering from your machine is it's working fine.
Exactly.
Yeah,
that's exactly
only a small amount of data that shows that there's going to be machinery failure. You know, most of your operation is that way, a little of it's that way. So you've got to kind of make that outlying data, that the fraction of a 1% of data that does that, you've got to give that just as much importance as the 99.99% of the data that does that, don't you?
Yeah, exactly. So I can't find the technique that I had in mind. Oh, I remember. It's SMOTE. SMOTE is the one that I've used in the past, and it's a very common. SMOTE. Yeah, it's one like machine learning technique for dealing with unbalanced data. And you're right that like when you're looking at cancer, that comes up a lot, and in general with medical applications, this is something that you're going to have to think about. Yeah.
I'm trying to find those. Here's the thing on towards data science. That sounds like a fairly reputable thing. Everything needs to know about SMOTE with a walkthrough of SMOTE in Python. Okay, I'll drop a link to that in the chat for everyone.
That's a really good question, and I think it's also like like it is like if you use traditional techniques for unbalanced data, like if you use traditional techniques and your data is unbalanced, you're not going to get great results. So it is important to kind of keep those things in mind, and also to kind of look at your data and realize, oh, my data is unbalanced. Just figuring that out, as you're analyzing your data is important. Yeah.
Cool. Yeah, I mean, I imagine just diving into how that works is probably going to be a whole session in itself, isn't it? It's probably a lot of. It's not like you can just take the data and just multiply it by 100 and just have lots of the same. You need to have varieties around it.
Techniques.
So
yeah.
Yeah. So Harry says, as a summing up of regression, I like this: an attempt to create a math function that lets you guess the output y for given input x.
Perfect. Harry, we're just going to invite you to the show.
Yeah.
And you can just like summarize things for us. That couldn't be said any better. Basically.
That'd be great. Yeah. As long as you don't deviate and start talking about assembly language. If you can come on the show next week and do all this for us. So for those who weren't with us yesterday, Harry and a few others and Bea and I had a great conversation about assembly language programming. So catch the recording of that if you want to geek out a little bit on why you should learn assembly. So Aaron actually asks, is learning machine learning these days needed?
So, I mean, what do you think, Tim? I think nothing is needed. Like you could spend your days on vacation on the beach and learn nothing and have a wonderful life. So is it needed? It's not needed.
There is a demand for it, isn't it? There is.
Yeah. Is there a demand for it? Yes. There's a huge demand for it. And I mean, I don't know if you've been following like the whole, like the fact that all these companies have been laying off people, right? Like generally the AI people are the last ones to be laid off these days, right? Because they're needed. Even Jim, we shared this story in our first show, like Jim was just reshuffled internally to the AI team because we need more AI people at Microsoft, right? So we need people with, if you already have the knowledge, then better. If you don't, we're going to teach you because we need you anyway, right? So AI is such a big area these days, and I don't see that diminishing. I just see that increasing. That I think anybody who's trained in AI and machine learning specifically is going to be in higher demand. I think that's just my prediction.
Yeah, definitely. People. I kind of think of it almost like a triangle. You can have at the base of the triangle. You can have a really wide group of people who know how to use it. Here is an API that does X. I'm going to put it into my app. So there's a lot of apps that leverage AI to do stuff. And so there's a lot of engineers who need to at least be aware that AI exists and what you can do with it to build apps. And then you kind of have going up the chain, you have the people who can use the tools that are being built to understand what regression is and how to kind of call the libraries to do regression. It's kind of a small group of people who kind of do that. And then right at the top, you've got the small group of people who actually build the code that builds the linear regression function. So you've kind of got there. It's almost like in any application space, you've got a small group of people who build the kernel for operating system, large group of people who build an operating system, then a huge group of people who build apps that sit on top. Same kind of idea. You have a small group of people who really know the fundamentals of machine learning, deep learning, people with PhDs who write papers, then a large group of people who build the libraries that's kind of sit on, that will build those libraries sit on top of that, and then a large group of people who build applications. That's kind of my take on the whole thing. And I very much sit right down the bottom in building the applications, not be your more kind of in the middle to the top kind of area of things.
Yeah, exactly. And there's a place for everybody. There's a place for everyone. But I do find that like the more specialized you are, then the more unique your skills are. And, I think you become even more valuable. So I think it's important to learn these things like from scratch as much as you can.
Yeah, and just having at least an understanding of the tools that are out there a little bit, because there's so many problems that you could throw some deep learning at, where someone like Bea would look at it and go, Nah, linear regression solves that problem, and it's a fraction of the compute power. So it's the more you're aware of the tools and techniques, at least just a basic knowledge of them, the more you can choose when you build your applications what you want to apply to the application.
Yeah,
that makes sense.
exactly. Yeah. So Javad has a question. He's asking if there are libraries available for SMOTE in Python, and there are. And I believe that the one that I used in the past is called Unbalanced Learn.
Okay.
Can we post that link?
Yep. Let's see. I'm putting a link here.
Yeah. Yeah.
Okay.
Yeah. There you go. Yeah, I think that's the one that I've used. Apparently it has other techniques too, or related techniques, variations of SMOTE.
SMOTE, yeah. SMOTEN. So SMOTE is synthetic minority oversampling technique.
Yeah. Exactly. Yeah. That's it.
Okay. Is this like a one-liner code thing? Is this the thing where
it kind of is? Yeah. So it's like the idea is that you're if you have a class that is very imbalanced, if you have two classes that are very imbalanced, let's say, and one of them is much smaller, the idea with SMOTE is that you synthesize data points for the one that is small, so that it balances with the one that is big, right? And then once you have that, then you can use a traditional machine learning technique for balanced data sets. But that sampling technique is not obvious. It's not easy, it's not like that easy, right? So there are techniques to kind of oversample in a way that it's real, that you're still like preserving the trend and the idea of the few data points that you have.
Okay, so if, for example, you had two outliers, one which had a value of 100 and one that had a value of 150, you wouldn't just duplicate that and end up with 100 100s and 100 150s. You would have 100, 101, 102, 103. Kind of it would work out some, I guess, randomness in that space of values to pad out the data set. Is that
that's correct?
Probably a horrible oversimplification, but is that the
yes? That is the idea. Yes,
cool.
That is the idea, that you don't duplicate points, you generate new points that are different from the ones in your little sample, but that still represent the general trend of the little sample that you have.
Yeah.
Yeah.
So again, it's trending. It may not be perfect, but it's better than nothing. So almost like using machine learning to predict the values that you would want to feed into machine learning.
Exactly. Yeah. So we have another question here from Marek that is interesting. I get that question all the time. Should I do a PhD? Will that help me? Currently, I have an internship. I'm thinking of going further in this direction. So I mentor a lot of college students, and not a lot, but a few college students. And I'm still like I still kind of go to the university where I did my grad studies a lot, and so interact with students there. And I get that question all the time. And usually the answer I give is like, depends what you want to do, right? So a PhD is great if you want to do research. I mean, it's essential. Like you can't not have it. If you want to do research at a university, if you want to teach, if you want to do research in a research lab in the industry. So basically those things, I would say, if that's your passion, I would say do a PhD for sure, because it will really help you kind of like accelerate your career. I mean, it's really the only way to do those things, right? And so yes, and then the students usually ask me this, but how do I know if I like research, And my answer to them is like, well, if you're a student, then just do some research, like, because you can certainly do research as you're in an undergrad or even in a master's. You can try it, right? You can collaborate with some other friends or with a professor and do just a little project, a little research project, or be a part of some paper that is being written with lots of people. You can take a little piece and try it, right? And so usually that's what I tell them, like, try it. If you love it, then do it. And then they also ask me, how do I know if I want to teach? Become a TA in a class. You get paid for it, and you get some experience in what it's like to teach, right? And if you like that, then go into a PhD. So there's that, right? Like if you know for sure that there's no way ever that you would ever want to do research, that you want to just create products, that you want to do something different from that, then the PhD helps a little, but not a lot, right? Like, so for example, for the roles that I hire for on my team, a PhD is not essential, but it helps a little because if I see somebody with a PhD, I would say, okay, this person really knows what they're doing. Like, they really know machine learning, so I'm not concerned about that. And I would want to like evaluate them in other areas, right? So, but I don't think it's as essential in the sense that I'm not so much looking for research ability. I'm more looking for other skills, right? And so in that case, is it worth the extra 4 or 5 years of your life and debt and whatever for a little bit of an advantage or in a product team? Maybe not, right? Because it is a lot of work and it is a lot of effort that you put into it. Yeah, and then the other question I get is like, but will I make more money? And the answer to that, again, it depends, right? Like, it's another 4 years or 5 years that you're going to be not making, making minimum wage instead of an industry salary. But then if you're going to research, then you make more money. So that makes up for it. So maybe long term, then that would balance things out. But if you get to the end of your PhD and you realize, but I don't want to work at a research lab, I want to do a product, then you don't make more money, right? And then at that point, I feel like you're kind of losing. So, but I think that at the end, it's really about what you want to do, what your passion is. Like, for example, my husband has a PhD. I don't. For him, it was very clear. Like, he really loved that world, and so it was very clear. So he works at a research lab and has always, pretty much most of his career has worked in research. In my case, I considered it very strongly. I had ideas. I knew the professor I wanted to work with. I kind of knew what I wanted to do, but in the end, I had like this conversation with myself, and I'm like, well, but what do I really want to do with this PhD? I don't know that I want to teach, and I don't know that I want to do research. And in the end, I really like what I'm doing now, basically. And then I decided not to go for it, and I don't regret it because it would be a lot of years of my life that in the end, I don't think, unless I would go into research, I don't think I would end up using those skills quite as much. So that's my long answer to it.
So
Hope it
basically,
helps.
it depends.
It depends, of course, each person is different, and I think it's about like kind of soul searching and realizing, what do I want to do in my life and how do I want to apply these skills, right?
Yeah, I'm just to your comment as well, Marek, about going further in this direction in conjunction with IoT. I mean, things like digital twins has been a big area of research in the past few years. I know a few professors up in Canada actually got a whole of research projects going on this area where you've got this virtual representation of the physical world. So you have your factory, you have sensors gathering data, and then you have a virtual factory with sensors gathering data, and then you build these machine learning models around it so you can use that to optimize process flow. If I change this is what will happen to this sensor data, what will then happen to this. And so you kind of use this to look at how can I optimize a process. And it's potential to be massive. There's a case study we reference at Microsoft about a Coca-Cola bottling plant where we reduced their carbon emissions and their costs, by kind of like quite a substantial amount. I think it was something like 10-15%. Which is quite a lot when you've got a massive bottling plant that's producing all the Coca-Cola for a country. So there's a lot of research in that area. So digital twins is one of the big areas around IoT. Obviously, as we bring 5G into factories, the data gathering, we can gather more data. So it's kind of optimizing the data inputs, data outputs. So it is a huge area to research if that's what you're interested in. I am going to ignore one comment from Harry. I'm going to ignore this one, so we're not going to assembly for 20 minutes.
Move on.
Moving on.
Heather has a really good question.
Yes, I was about to bring this one up actually. Yeah.
So we actually have that in the code. I'm not exactly where. So you're totally right that so let me actually explain what he's saying. So you see where it says linear regression example, there's like a y equal to b plus mx, right? So there's like an equation that you find during training that represents that line, that prediction line, right? And so what happens is that you have the x and the y, and during training you learn the b and the m. So that's how you find that b is during training. And I think that we have somewhere in the code where we actually print it. We actually, because you don't need to actually know the number. Then once training finds it, then you can just use the API to make predictions. But at one point we actually print it as like just as a curiosity. I'm gonna try to find where we do that in the code. I actually think it was maybe in last week's notebook that we did that. Let me look.
I mean, let's actually work through the code. Actually, that's probably a good thing to do. Let's actually work through the code. So I'm going to dive straight to the solution notebook rather than you watch me copy and paste in. So what we did in the videos for this week, I say what Bea did in the videos for this week, is looking at pumpkin prices. So
sorry.
So the idea is, if we have data about pumpkins, can we use this data to predict pumpkin prices at various times in the year? And actually, if we can walk through this example, we actually show that result coming out with the values. I'm going to double check that I'm not speaking rubbish. One of these we definitely do it. One of these we definitely do it. If I'm for the right notebook. If I'm for the right notebook, then I think that might be better. Is this the one that prints it out? One of them does. If not, we can, once we've got it, we can actually print it out. That's me zipping around in here. One of them does it. We can print it out, but if just let's actually work through this notebook then, and we'll kind of see how it's all calculated, and then we can actually print out the numbers if we want it, but we don't kind of need those, do we, Bea? You can just put in inputs and get in outputs. The model does that for you.
Yeah, we don't need to know what they are. Like, once you've trained it and you have them, then you can just then they're like remembered internally, so you can just make predictions using the model that you're trained. But I know that we printed them, and I'm still looking for it and I can't find them. But in one of the examples, we actually print them just as a curiosity. It's like, remember that math that you learned? You can actually go see what those values are that you learned, but I just cannot find it.
Yeah, I think we do it in the video. I don't think it's done in the actual curriculum. I think it's just done in the video.
Oh, really?
So, yeah.
Okay,
maybe.
so then maybe I just added it.
But let's just work the code. Then I think we
so watch the video, because yeah.
Watch these videos. I'll drop the link back in the chat. But if you didn't catch it earlier, /MR beginners videos. But if you watch the videos, we do work that out, because it's not the diabetes data set, is it? It is. I say that.
It's the pumpkins.
It is in the pumpkin one, isn't it?
Yeah.
Yeah, it's not in this one here. Is it this one? Yeah, it is in the pumpkin one. But I mean, let's dive into the pumpkin one. Let's actually look at some code briefly, and I'll just kind of show you what we're doing. So we've got this pumpkin data set. It's kind of the US pumpkins. And we load it up. Just make sure I've got the right kernel activated. For some reason, my code spaces through Edge is not actually bringing up my terminal.
Well, I'll answer Jawad's question while you're figuring that out. So he says, thanks for explaining outliers. How can you handle missing data in linear regression? So linear regression, so you have whatever data you have. And by finding that line, it's kind of, you can think of it as it's like handling the missing data that you don't have, right? You're always going to have missing data because you're not going to have a value for every single X, right? And so you have the data you have, and then the regression will do the best that it can to find a line that fits your data. If you have a lot of data, that line is going to be more accurate because it's actually going to represent a trend that is actually there. If you have very little data, it will still fill in the missing data. It will still find a line that fits that data. It's just that it's not going to be very accurate because you didn't have a lot of data to train it. So it's just it might not give you the best predictions, but it always does something. Yeah.
Okay. Cool. Okay, I think I got it working. So yeah, I'm just walking through this code then. So we're loading up a CSV, and one of the questions we got asked yesterday was, how much Python do I need to know? As well, not a huge amount. It's not complicated Python. It's just understand the libraries, isn't it? More than anything.
Mm-hmm.
So we've got these pumpkins. We've got this pumpkin data. Different types of pumpkins. We've got prices, dates, package sizes. 1 1/9 bushel cartons and other such bizarre package sizes. And so we need to contain this data. We need to actually use this to build a model. And then we need to think about having good data. So I guess going back to that question about missing data, when we've got this data here, you see we've got some missing fields. So it's kind of important that we check our data, isn't it, to make sure we're not missing any data. And so we can run this function here, is null summed, and this counts the number of fields, well, the number of null values in the fields. And obviously, if we have lots of null values, then we can't use that row, if that applies to what we care about. But we care about the package size, we care about the price and the date, and these all have 0 missing values. So we kind of know that our data, the data we've got, is kind of a good enough set of data. And then once we've got that, we want to work out what columns we want. We don't care about the whole thing, so we can strip down our data. And again, it comes down to knowing the Python libraries. Lock. I still don't know what lock's supposed to stand for, but the idea of lock is you then use that to pull out the columns that you want. So we're saying we care about the package size, low price, high price, and date. And then we actually calculate the price. We take, because obviously in a date, there's like a price range. We want the average, because no point of low high, but we want the average. We want to get the date time as a month, because we only care about what month it's in. We kind of build a new data frame with that in. So we take this data, just put it in a new place, and then we look at converting the price, because there's 1 1/9 bushels and half bushels. And so we convert the price to bushels. So this is kind of the data cleaning you have to do. You have to kind of go through and say, how do I normalize my data? If my price for these rows is 1 1/9 bushels, and I have no idea what a bushel is, or this is half a bushel, we need to think about what's the convenient unit. So if we just say, just give me the rows that are in bushels, and if it's 1 1/9, we divide it by 1 1/9. If it's half, we double it. So we've kind of got the price per bushel. That gives us our data. And then try to make sure I run this cell to get the data. So we've now got, my scroll with my mouse isn't knackered. We've got price. This is the price per bushel. So if you look here, this high price of 15, it's 15, I guess, dollars for 1 1/9 bushels, which means the price per bushel is divide that by 1 1/9. This one here, it's $15 for half a bushel. So 1 bushel is 30. So that's kind of normalized our data. And we've got our month as numerical values. And then once we've got that, we can do our plot to kind of look at it. That's kind of our chart. So we're focusing today on actually kind of visualizing and cleaning the data. We're not actually going to be building regression models today. We're kind of getting that data ready. Going back to the questions about outliers and wrong data, you need to make sure you've got the right data going in. If you want to make a prediction, you can't use the wrong data. There was a classic example of skin cancer prediction where they looked at moles. I don't know if you've heard the story, Bea, but they looked at moles and they photographed a load of moles on people, moles on people's skin, not the furry animals, moles on people's skin. And they used that to build a data set for a vision model to predict whether a mole was cancerous or not. And it turned out the vision model was highly effective at detecting rulers, because whenever they had the pictures of a cancerous mole, it always had a ruler against it to measure the size of the mole. Whereas all the data that didn't have cancerous moles didn't have rulers. And so what they were measuring was rulers, not actually cancer. It's kind of the same thing here. We need to think about what is the right data, bring in the right data. And then once we've got this and cleaned, we can actually look at it and then use this to make decisions. We can see here, we've got a price trend here, and we can build a regression model. And so, a little bit teasing, next week is when we dive in more into this regression model.
Yeah.
And we'll actually build out the model.
Yeah, and it actually makes sense if you think about it for pumpkin prices. So we have only data for August, September, October, November, December, which makes sense because, like, if you have ever had a vegetable garden, you know that vegetables don't grow year round, or the same vegetable doesn't grow year round, right? There's a certain season for them. And it also makes sense that the price would go up in September, October because of Halloween. That's when there's more demand. And it also makes sense that, December, everybody has forgotten about pumpkins by the time Christmas comes along, so they would be cheaper then, right? So you can also kind of use a little bit of common sense to look at your data and realize, I I get it. I understand it. It makes sense to me. I can explain it, you know.
Yeah, so we kind of extrapolate this line, looking at these 2 months. It's like, oh, look, the price is going up.
Yeah.
So just based off that, the trend is it'll be even higher in October, November, and kind of, you know, going off the top of the screen in December. But it's not like that. We need all this data to do it. Now, obviously, we built this by cleaning our data. We went through, we dealt with the bushel sizes, and Lawrence has a great question on cleaning data. So one for you, Bea. I need a way to identify count name duplicates to clean and merge in my CRM. For example, IBM equals I.B.M equals IBM, Inc equals IBM Inc equals International Business Machines, etc. So your thoughts on data cleaning when you have multiple representations of the same thing?
Yeah, just look at all the representations that you have and replace them all by the same thing. Replace them all by, I don't know, IBM or whatever, right? Maybe with a regular expression, maybe with a list of all the possible things that you've seen for that particular meaning, you know, for in this case, for identifying IBM. Yeah, you can easily look at your data and see, you know, what are all the things that I get for that field that mean the same thing, and then just, you know, come up with a rule for that.
So it is a manual rule-based piece of work rather than there isn't any kind of tooling that's smart enough to do that.
You know, that's the thing that now with like these larger models, like I can see like GPT-4 and whatever, like being used to kind of simplify the data cleaning kind of scenario. Like, but I would say like today, there's still a lot of manual work of like analyzing data and figuring out what are the different things that mean the same thing. You know, there's still a lot of like actual human type thinking and decision making that goes into making up these rules. But I can certainly see that changing very quickly as GPT-4 is, or even without GPT-4, as like larger models are start being used to create tools that help you with this kind of data cleaning. Yeah.
So Harry chimes in on this to say, I worked on a system trying to do that jumbled name matching. We never really found a good way to do that, but curious if others have a practical solution. So what you're saying, Bea, is you can't, it's hard.
Yeah.
There is no practical solution.
It's hard. Yeah, but I think I see this as being a great business idea for anybody in the call. If you want to create a business that uses machine learning to clean data for machine learning, you know, honestly, I think that this is something that, let's say, if you took this to GPT-4, it would be able to identify, oh, these things are all similar and they're all mean IBM. Like if you threw a bunch of, you know, what is it, like account names, right? If you gave it a lot of account names and said, some of these are duplicates, can you identify the duplicate ones for me? I bet that GPT-4 would come to you and say, oh, I think that IMB equals to I.B.M equals to IBM Inc. and whatever. So I actually think this is a great business idea. And maybe it already exists, but I haven't seen it. Yeah.
I guess because one of the limits we have of models like, well, any machine learning model is the amount of data you can kind of put into it. So with GPT-4, you're limited to 8,000 tokens or 32,000 tokens if you pay for the extra thing. See, you might have better put your entire data set in, but you could put chunks of the data set in and then use that for it to come back with, here are all the synonyms of IBM. It's IMB, I.B.M, International Business Machines. And once it comes that, you can then feed that into like a rules engine, just a simple find and replace across your data.
Or even like filter by account name, do a list, like a Python list, sorry, a set. It's like, so you filter by account name, you get a list, you do a set, which means that it just removes all the duplicates and it just gives you like one of each. And assuming that you don't have billions of account names, you know, just that set, you should be able to feed into GPT-4 and ask it to find the duplicates for you, and then use that answer to kind of group things, you know, obviously validate the answer, because you shouldn't just trust everything that GPT-4 gives you. So look at it. Does it give you a good answer? It does. If it does, then do what it, you know, execute that suggestion and remove, you know, and bundle kind of the similarly named account names.
Yeah, either that or just Mechanical Turk it. You know, just going back to Bea, you're saying about there's humans involved. So Mechanical Turk is a service where you pay people to do the data cleaning for you. I mean, that's just actually how companies like OpenAI have worked. You know, to build these huge models, they pay a lot of people to do this kind of manual data work, whether it's analyzing the data, cleaning the data, whatever. Yeah, there's plenty of news articles about the different places around the world where these AI companies get people to do it, because you need humans to validate the data to build the models. I mean, eventually the models will be good enough to do it for you, but right now you need a lot of humans. I mean, just data labeling. You know, just that labeling thing.
Yeah, and in the case of OpenAI and GPT models, like there's one technique that they came up with that is entirely based on humans or relies on humans, called reinforcement learning with human feedback, which is a technique that is essential for the amazing kind of alignment that they're getting, like alignment with human expectations in the results that they produce. And that's a manual technique. It's literally just like a technique where they produce, you ask it a question, it produces two different answers, and then you get a human that says this answer is better than that one, and then that gets fed back into the model. The model is fine-tuned with that information just so that it kind of can produce a better answer next time. And that's kind of a manual process, in the sense that you need to have a human involved and deciding what the best answer is. But it's extremely effective. They have found that they don't actually need that much data and that many humans to see huge benefits even in the large models that they create. So it's really effective.
And it's almost getting built into some of these models as an end user. So if anyone's got an Alexa, apologies if anyone's got one, I've just set it off. But you know,
she's over there. She's over there. I have you wearing my headphones, so she can't hear you.
I mean, I've got one in my kitchen, and I haven't thrown it away yet because it's the only one that connects to the shopping list app I use. But that's the only thing I ever use it for. But I'll be,
same.
Alexa,
here.
add this to my shopping list, and then Alexa will come back and say, I've added this to your shopping list. Was that right? You know, like, Alexa, add cornflakes to my shopping list. And like, oh, I've added chocolate syrup to your shopping list. Was that right? Like, no, of course it's not right. I feel I spend more of my time saying, no, that's not right. But that's kind of built in, isn't it? That's the reinforcement learning through human feedback, is that when I give Alexa something, it says, I think it was this. Am I right? If the answer is yes, it does. If the answer is wrong, it says, oh, okay, I'll undo what I've just done. So it's kind of leveraging me as the end user to help drive that.
Yeah, for sure.
So Lawrence comes back to say ChatGPT recommended the Levenstein distance to compare two strings. Yeah, it's a good way of measuring how similar they are. Not sure how that would work with IBM and international business machines. Right. I imagine the Levenstein distance for that could be quite large. Exactly. But that's the way to do it. And then ChatGPT proposed some code that didn't work.
Yeah, I'm not sure that technique would fully work for the reasons that Jim just mentioned. Like, it mostly compares like similarity between two strings, but international business machines is very different from IMB or hi.b.m, and so it would give you a very large distance there. So I'm not sure if it's. I think it's a great technique that might work in many other scenarios. I'm not sure that's exactly what you need in that specific scenario. Yeah,
it's interesting that ChatGPT recommended that. I mean, it is a way of looking for similarity in strings. It just might not be the best way for. So Marius asks, aren't data drift detection mechanisms and algorithms? So are there data drift detection mechanisms? Are there ways to look at I'm guessing, Marius, and correct me if I'm wrong here, but if you're looking at like a general trend, is there a drift in there that the data kind of pulls it one way? Are there ways to look for that and kind of detect that?
Yeah, I'm assuming that he means like drifting, like data drifting, like over time. Like, let's say you fit your model with some data, and then your data starts drifting, and then your model is no longer accurate to predict the new data, and then you need to kind of like compensate for that. And there are lots of techniques. There's tools. There's the ones that you mentioned for sure. In fact, I think the KS is probably the one that I would say it's most popular.
Kolmogorov, Smirnov, and Page Hinckley are the two.
Yeah. So yeah, for sure there are techniques that deal with that, and tools also. I've heard of people like integrating those techniques into tools, and to help them deal with data drift, and
Which I guess, thinking about pumpkins over time, there is, yeah, kind of there is a trend and it drifts the other way over time. So
Yeah, and it could be like next year they're all more expensive, and your predictions are no longer super accurate, right? Or it could be that there's a new, some TikToker that starts putting pumpkins out at Christmas, and then somehow it's no longer fashion or trendy to use them to put them out for Halloween. Now it becomes a Christmas thing, and then the data starts drifting to the right, and then they start becoming more expensive at Christmas and cheaper in October. And so those things you need to be able to detect, because trends happen. Like things change over time, and you can't just have like a model that just works in one way and it's fixed just because that's what you trained it with, right? You need to detect those things and be able to adapt to them.
So last Halloween, I did a live stream with a couple of colleagues, one in San Francisco, one in Sydney, and we dressed up and we got pumpkins, and we actually put lights in the pumpkins and coded up the lights. Except my colleague in Sydney, Renee, because they don't get pumpkins there at Halloween because it's springtime, not autumn time. So she had a pineapple. So who knows, if that gets famous and everyone starts using pineapples with lights inside for Halloween, then yeah, you get that data drift.
Totally.
Cool. Another question.
I like that. I like that trend. Pineapples.
Yeah, pineapples, watermelons. We should do lots of other things instead of pumpkins. So Maria's got a question. We've got time for, I think, one last question. In the absence of prices, the B fill and F fill methods should not be used. Missing values should be calculated based on remaining values if there is such an option. Is it true? Is this a true statement?
I'm not sure. I'm not sure what you mean by B fill, and I'm not sure what you mean by that. But so in logistic regression, like in this basic technique that we're showing you here, the missing values are calculated based on all the other values.
So yeah, these are pandas functions to fill in data.
Yeah, I see what you're saying. I think maybe in the cleanup of the data, I think that's what he means, in the cleanup of the data.
To fill holes in the data.
Yeah, to fill holes in the data. Yeah, and I mean, if that's what you mean, if that's what the bfill means, then yeah, I mean, I have seen people do that. That's not what we do in this example. Okay, method to use for filling holes in reindex series.
So this is like
for series.
So if you've got a whole lot of data, so you've got like, say, time series data where you got readings every minute and you're missing a value here, you could take the one from the previous minute or the one from the next minute.
Yeah, okay, yeah, I see what you're saying for time series. Yeah, I mean, that's a valid technique. I have seen people use this. That's not what we do in this code. We're really just looking at the trend of the data that we have there, and we remove any data that is not filled, any NaN. We remove anything that is null, we remove, and then we just use the data that is there. In this case, we can kind of do it because we had so much data and we wanted it to run fast enough for you guys. So we had the luxury of being able to simply not use the values that were null. Right.
So I guess this comes back to the discussion we had earlier about domain expert. To find out whether it makes sense or not, you need to have a domain expert to say, yes, that is a valid thing to do or not.
Yeah, exactly. Yeah.
Cool. Awesome. I mean, at that note, we are practically out of time. Some great questions. I hope we've answered everything that you want to that you were hoping for. Sorry we didn't talk about assembly language. We ran out of time, Harry. Sorry about that. So Bea and I are back next week. So we'll be dropping more videos on Monday. Our video series, we'll get 4 more videos. We dive more into linear regression, and we actually run a few things and look at predicting pumpkin data. I won't give the game away as to how successful everything is, but they drop Monday morning. If you signed up for the series, you'll get a link to that when it happens, 9 o'clock Monday morning Pacific time, and you better go and watch the first video, the new ones, and then follow on, watch the rest of them. And then Bea and I will be back Thursday and Friday next week to kind of carry on working through this regression projects and answering more of your questions. Been some great questions today. We won't be doing deep learning. Sorry, Marek. We're just covering classical machine learning here. But with a link's been put in for our survey. We'd love your feedback. This is kind of the first time we've had this idea of live videos and then Q&A sessions, office hour type sessions afterwards. We love your feedback whether this works or not. But if you want to dive into deep learning, there is a free text field in that survey. Please put in there what you want to learn. We want to make sure that as we do more sessions through the Microsoft Reactor, they're what you want to learn. So the more people who ask for deep learning, the more chance there is of us bringing in some deep learning experts and covering that. So please, please, please fill in the survey. Let us know what you think. But otherwise, thank you for joining us. It's been a lot of fun. And hopefully we will see you all next week for more machine learning for beginners. So enjoy the rest of your day, everyone. Thank you, Bea. Thank you, everyone.
Thank you. Bye.